Okay, y'all, we're back, and you know what else is back is those warm temperatures, 74 degrees out there, and we were up to about 86, and I'm kind of getting tired of turning off the air conditioner before each webcast, but it's still necessary, and it'll be that way for probably through the weekend and part of early next week. A lot of the south still running very warm. So let's take a look at the charts and see what's going on. And this is a graphic for the new book that's coming up, the Instability and Shear book. And this is going to be one of the graphics for one of the pages. So yeah, you'll want to pick up a copy of this when it's available. And I'll discuss the book once it is ready. And I think we're down to maybe about a week before that comes out. Okay. Let's go into the chart sequence. Let me get this out of the way here. There we go. We definitely do have some polar air way up north in the Hudson Bay region. Pretty much centered right over Baffin Island, extending down into the Hudson Bay and across the northern prairies, and even a piece of it down into Washington. And you can see the 540 line, the southernmost blue line, well south in Oregon and all the way down in Montana like that. And then across the Great Lakes. But this means temperatures are running very cold in the Pacific Northwest there. And where the warm air is where we have the thermal ridging. So that's going to be Texas, Oklahoma, Kansas, New Mexico. We should see some warm temperatures there. And we can paint out the fronts very quickly. There's obviously some troughing in here, so this looks like a warm front in Colorado. And then it pulls up through Wyoming, and then down through Idaho, and then probably south is a warm front through Northern California like that right there. So that looks to be the frontal analysis there for this evening. And then where we have all this high pressure across the eastern U.S., that's an area of frontalysis. So what you're doing is you're spreading the temperature contrasts apart and breaking up whatever front is through here. Now, if you do go through the data and start looking, you might be able to find a thermal gradient in here if you look hard enough. But if it's that diffuse and you have divergence underneath that ridge, that's going to make it even more diffuse. So really, it's kind of inconsequential. Another little cold system through the Canadian Maritimes there in Labrador. And that's on its way out. So that's the weather picture there at the surface. So yeah, let's take a look at a couple cross sections. It's a good time to do more of this, and this is what you don't want to go straight into this. You want to have that grounding of what's happening across the U.S. So you remember we went through the charts and we were looking at maybe something like this. So we got to keep that in mind. We're visualizing stuff, not just going blindly by the graphics, and we know that this is all high pressure through here with ridging all the way down to the East Coast like that. So now we've got a better idea what the plot is going to show here. So let's check it out. We probably want a north-south or northeast-southwest plot. So let's pull one up, Del Rio to Green Bay. Okay, so this is obviously the East Coast, or I'm sorry, the North U.S. on that side and the Southern U.S. here. And another way you can tell is to look at the WMO identifiers. So look at the third digit. So you see we have a 2 here, and then that goes up to 6, and then 5, and then 6. So it's going up as we go this way. The higher third digit number is what you find in the northern U.S. So that's kind of a trick you can go by when they're only giving you WMO. All right, so we know that this is Texas down here. This is going to be the Central Plains, and this is going to be the Midwest and Great Lakes here. So going back to that mental map of what we have, we know that there's a frontal system in Texas, so somewhere in here, and that's likely going to slope up and over the cold air mass. So we can actually see this right there, and in fact I'll just draw it out here. That appears to be the frontal boundary there. Maybe something like that, perhaps. And what you'll notice here, the red lines, theta, potential temperature, we're going to find those increasing with height across the whole map, but they're going to increase faster with height where we have an inversion or where we have stability. And when those red lines are far apart, that's where we have an unstable layer. So what this chart is showing is over the Great Plains, we have a relatively stable layer down here and fairly unstable aloft. So what we have here is probably a tropical air mass atop a polar air mass with an inversion aloft. And that makes sense because you're going from cool air to somewhat warmer air where your tropical air is. So that's what's going on there. And then the green is mixing ratio, so that's kind of like dew point. So it looks like there's a little bit of moisture kind of trapped in that polar air over Kansas. That can be beneficial when you have storms in that area. And let's see, what else do we have here? We've got, that's probably the important ones right there. And then the wind barbs, of course, showing the southwesterly flow. And look right here, we've got easterly flow right there. These barbs are oriented with respect to north, south, east, west. You have to kind of keep that in mind, and sometimes you have to figure this out before working with a chart. And this is showing easterly flow at this station here, and then northerly flow where these barbs are here. So it looks like there's some cold northerly flow coming in through the western Great Lakes. And of course, with that strong northerly flow, we find some very tight packing of the theta contours right here around Lake Superior, and very cold temperatures here. We've got this pocket of very low potential temperature values. So we're seeing 280 here compared to 290 over the Great Plains and 300 over Texas. So that represents temperatures going down as you go towards the Great Lakes. So where we have this little dome there, the dome is cold air over the Lake Superior area. Or actually, this is Green Bay, so that's going to be Wisconsin there. So cold air over Wisconsin and northerly flow coming in there. And then over the Great Plains, a little bit of easterly flow. And then as we move southwest, we pick up the southerly winds, and there they are right there. So many different ways to visualize what's happening aloft. And we can probably take one or two more. We can try Del Rio to Bismarck. Kind of a similar pattern there. Looks like a front all the way down to Texas. And colder air up there in the Dakotas. Looks like a little bit better moisture in this part of Texas. I can see 4 grams per kilogram right there, and then 6 and then 10 right there, but it's a very thin layer, under 850 millibars there at Del Rio. Okay, we'll try Lafayette to Green Bay or Slidell. And on this analysis, very hard to tell where the frontal position is. There might be one possibly right there. This is where I would have to go back and look at more data. We know that this is the cold air right there, but it's a little bit indeterminate over the Mississippi River Valley there. All right, give me just a second here. Okay. And let's try one more east-west one. Maybe, let's see, Denver to Wilmington. Yeah, we'll do that. So we'll go across the Great Plains from east to west. And now we're seeing that very noisy, wavy flow. And this is caused by the way it's analyzing the data. So that's just kind of an artifact. So we kind of ignore that and just kind of look at the data itself. For example, the very strong moisture right there over Nebraska or Iowa, somewhere in there. So picking up a little bit of moisture there, something going on, and we can see southerly flow through that area. So maybe a little bit of moisture advection coming up from the south. And that's about it right there. So that's a look at cross sections. So isotropes are definitely your friend, and that's these red lines right there. So that's the 310 Kelvin isotrope potential temperature. It's basically a dry adiabat visualized aloft. In parcels, what's important about this is if there's no diabatic processes going on, like removing moisture from a parcel or adding moisture, that kind of thing, parcels will tend to cling to their isotropic surface. So if you have a parcel right there and you're able to force it to move this way, it's going to want to ascend as it moves to the east there. And indeed, the wind barbs here showing a little bit of westerly flow. But again, these waves here, I would be kind of cautious about that. It looks like that is kind of a problem there with the east-west grids that they use there. And we can resolve some of that data to the SKUTs. It's another way of visualizing the data. So you can see right there at Del Rio, have an inversion there, and this is a subsidence inversion. So all of this is basically tropical air. There's no polar air here. Just we have a little bit of moist polar air, or moist tropical air underneath this inversion, and above that, dry tropical air. It's all warm air. So we're not going to pick up the polar air until we get a little further north. Now here's the polar air. This is Fort Worth. And you'll notice that the dew point plot here on the left tends to follow the temperature line. And this is at about the 2,000 or 3,000 foot level. So we've got a little bit of a polar front surface at about 900 millibars, about 3,000 feet up. And the wind beneath that frontal inversion is out of the southwest. So that's going to be a retreating boundary. That's going to be maybe a warm front lifting to the north towards Fort Worth. Going a little bit further northwest, we can go to maybe Norman, Oklahoma. And this has the look of a subsidence inversion. I'm not too sure there's polar air there. There probably is, but the sounding doesn't have the characteristic look of polar air. Although, look at those temperatures. Yeah, 50 degrees, that's going to be kind of cold. So, yeah, this is polar air. It's just the moisture is not following the temperature line in that classic way that we expect. So you'd have to use a little bit of common sense. So let's go up to Springfield. That's going to get deeper into the polar air. And that's the kind of frontal inversion that we look for. Again, it's going to be a retreating boundary there with south winds about 20 knots. So that's one way you can anticipate the movement of fronts before even looking at surface trends. And now we're up at Lincoln, Illinois. Cool temperatures there, 50 degrees near the surface. And then they warm up to about 60 degrees aloft, up at about 6,000 feet, so a little bit warmer up there. That's the top of the polar air mass, right there at that level, up at about 6,000 feet. And even there, winds out of the south, but a little bit shallower down near the ground, they are out of the northeast. So some of the retreating is starting aloft, but not so much at the surface there in the Chicago area. Okay, let's see. What do we have next? We can take a look at a polar orbiter data map there. Let's zoom in a bit. So this is going to be earlier today. And we've got a lot of stratus and fog across Kansas and Oklahoma. So this is probably associated with that warm front down to the south. down in this area. So there's probably a little bit of very shallow lift, perhaps. We saw that in Kansas, you remember earlier I was saying Kansas had what looked like kind of like some trapped moisture. Very humid, high relative humidities, add a little bit of lift north of the warm front, and the result there is stratus and fog across Kansas there. And we'll take a look out west. I can see the cirrus starting up there in California, and transverse bands, gravity waves showing up here. So probably a fast jet there in California, Nevada, and maybe a storm system a little ways offshore. Let me take a quick look at the lakes in Saskatchewan. Looks like they're not frozen up yet. This is far north Saskatchewan and the lakes there. There is snow on the ground in that area, but warm lake winds. And look at that, we've got a lake effect wind. So it's pretty obvious which way the wind's blowing there, right? It's out of the southwest, picking up that moisture there, a little bit of humidity coming off the lakes, and that condenses, and we get these bands of snow showers or light rain, depending on the temperature. And the other lakes up in Northwest Territories, they're clouded over. Actually, there's Great Bear Lake. Looks, even there, still not iced over yet. The upper air analysis, we'll take a look at that there. About 5 days ago, it looked like this, troughing on the East Coast. And you remember that vortex there over Ontario merged up with the vortex on the East Coast. And keep an eye here on Alaska. A little bit of a trough going through this ridge. And you'll notice it comes down the backside of that ridge right there, and then gets carried into California, and now we've got a little bit of development off the coast of Washington. All right, so there it is, troughing on the west coast there. And if you just run the animation, it looks like something just kind of went eastward out of Canada, but what actually happened was that trough moving gradually southward down the west coast there. So it can actually help to kind of like run your animations backwards and follow where the features are coming from. So there's the Canadian produced North American weather. And we can take a look at the temperatures up north there. 0 to 5 Celsius, that's going to be 30s and 40s in Wisconsin and Minnesota there. And then up in the prairie provinces of Canada, looks like temperatures about teens and 20s. Let me see what time of the day that was. That was 1 p.m. So yeah, that's kind of cold there in Canada. And then up over the lakes there of Northwest Territories, temperatures right around 14 to 15 Fahrenheit. All right, so let's see here. Let's look quickly at the 850 millibar analysis. This is up at about 5,000 feet. And we did those cross sections there across the plains, and we saw that there was northerly flow across Wisconsin, and there certainly is. There it is, winds coming out of the north there. And then on the other side, we pick up that southerly wind in the high plains. And we can definitely make out the boundaries here. The orange and red lines, those are going to be your isotherms. So going by that gradient and following that packing there, there's our polar front. And it looks like it comes southward maybe through California like this here. So we go from +4 there in Washington, and we warm that up to 5 above in San Francisco. All right, there's our infrared satellite imagery, and let me take a look at the chat and see what we got going on here. We have Electric Dog here, and Justin Pulliam. Megan John, 30 degrees and snow falling in central Minnesota. Snow, I can't even imagine that. I was outside earlier this afternoon and had to come back in because it was getting hot out there, and the AC inside felt really nice. Fun with Tech is here, and Lexi Pink, Sin Walsh. David Moore, over 90 degrees yesterday in the Metroplex. Very chilly most of the day there. Temperatures tomorrow back in the 80s. Burl H. enjoyed the webcast archive on the Hove-Muller diagram. Yeah, that was a ways back. At least a year ago when we did that. Michael Burrell with us, and Ryan Toomeys. High tide wreaking havoc with the king tides and full moon. East Coast communities flooding pretty good. High, strong easterly, windy conditions not helping either. Got Carl Berghoff with us, and Nathaniel Peets joining us, and let's see. Carl Berghoff said it was 34 for a high, and if I recall correctly, you're up in... it always happens when I'm on the air. Wind's blowing good there where Ryan is, 84-degree high. Michael Burrell says, smash that like button, guys, and give me just a second. Hey guys, okay. Yeah, Ryan Toomey's telephone. Okay, yeah, let's continue on, and I guess we can just check out the forecast. Kind of a quiet day. A little bit of, looks like a little bit of upper air convection maybe there over Memphis. And the satellite showing things pretty clear across Texas. And looks like, yeah, there's that upper air energy there over the western U.S., and looks like a little bit of a system coming over the Dakotas and Minnesota area. Not very well organized. But, yeah, moisture is kind of flowing north into the northern U.S. All right. The water vapor imagery, which we're looking at here, showing this could be either, I mean, it looks very white. In the summer, we would be talking about moisture everywhere. But this time of the year, when we have cool temperatures at the surface, it could be either cool temperatures at the surface or it could be moisture. So there's a little bit more difficulty using this in the wintertime. What we do know is right here in Texas, that is definitely dry. So if we go to the SKU-T analysis, if I can find out where I moved it. Yeah, there it is. We'll use that one right there, 480Z. So I'll take that to Lake Charles, and we should see a fairly dry upper air plot there at that station. So they're probably right on the edge, but there's some dry air, and then Shreveport a little bit to the north. Yeah, some more dry air right there. So that's what's going on there. So in the wintertime, you kind of go by the red. You know for a fact that that's going to be dry there. And then what's around is a little bit less certain. You kind of have to use common sense. Up north is really where the uncertainty is. And down south, that's more reliable. So we can say over Arizona, probably a very humid column. And let's check that out. Tucson should show moisture in the upper levels, and there it is. Base is about 22,000 feet. Tops at about 37,000. Some good cirrus and cirrostratus there. And then one more Flagstaff showing moisture. So this is basically the Pineapple Express coming northeastward, bringing up moisture from the subtropics. And I wonder if we have a more zoomed out view. Maybe I can show that to you. I'm going to do the full disk imagery and see if I can bring up the water vapor imagery. And let's see here. Okay, satellite imagery, we go to the full disk. Actually, I want to go out west. That's the goes east imagery. So we scroll down a little bit, and there it is. There's the full disk image for the west. And what we want to look at is the water vapor imagery. So let me set that up. I'm sorry, that's the IR. And this should kind of show us where some of this moisture is coming from. Let me enhance that too. Okay, so that's a little bit different presentation than what we usually see. And there it is. There's the moisture coming up in Arizona. So obviously this has an origin from off the coast of Mexico. Could be tropical moisture from these tropical cyclones and systems off the coast of Acapulco there. So let me run that back. That's going to be that patch of cloud right there. And then during the day today, it moves up into Arizona there. So a lot of times if we have a very powerful weather system across the western U.S., and fronts in that area, and you bring that moisture northward, that can really feed things big time. That's kind of like turning the fire hose on those systems there. Okay, so it's about time to look at the forecast. Starting out tonight, we've got a very definite handle on what's going on. There's that front right there. You can kind of see some of that upper level convection there in the Memphis area. And then for tomorrow, on Saturday, we're going to see one wave pulling up out of the Dakotas. And it looks like the system starts crossing the Rockies. A few contours across Utah and Idaho. But it's a little bit ambiguous. I'm not sure where I would place that front. Yeah, it looks like it's still hung up there in Nevada. So I'm not going to bring it all the way out to where these contours are here. So I'm going to go with maybe tomorrow night, something like this here. And the warm front, that's definitely through Missouri, through Nebraska like that. Okay, I'm trying to find purple on here. Oh, no, okay. Guess I thought I had purple on here somewhere. Okay, P. Yeah, there we go. Now we can draw our occluded fronts. So we'll take it into Sunday. That system moves eastward through the Great Lakes, cold air advection in that area. And then for tomorrow night, we're going to be looking at a new front coming into Missouri and Oklahoma. There's that cold blast coming southward. This will probably get hung up once again in Texas. And that appears to be the analysis for tomorrow, for Sunday. And then for Monday, let's see. Oh yeah, look at that. Some showers and thunderstorms in Ohio and Pennsylvania there. So we've probably fed this with a low-level jet on Saturday and Sunday. And there it is. That banding of pressure gradient. Kind of a straight flow up there from South Texas. Then for Monday, there is the front stalled along the Red River in Texas. So these are some very lethargic weather systems coming out of Canada. And it's actually the very strong zonal component that's keeping them from coming south. So for Tuesday, it looks like finally we get a push of cold air into Texas. And you notice that gradient right there in Nevada. A little bit of northerly flow coming into that area. And then for Wednesday, yeah, now we got a good push of Canadian air coming through. So Thursday we should see a cool down. And you can see the pressure gradient right there in West Texas all the way up to Albuquerque. That's the backside of a front there in the higher terrain. And then across Nevada, there's even a pressure gradient through here. So yeah, I'm going to put that front through Las Vegas and Flagstaff, and then maybe up to the Sierra Nevadas like that. So that's what the map looks like on Wednesday. Then for Thursday, big high coming through the Great Lakes, 1034 millibars. Lots of cold air advection. Looks like a bit of a strong system in the northeast U.S. Let me go back a little bit. That's going to be kind of an Alberta clipper coming through the Great Lakes. That's going to be next Thursday. And then that emerges out into the northeast U.S. Lots of gusty winds, some snow showers. But definitely not, that's not going to be a nor'easter. Nor'easters have a track kind of like that, and they engage more of the moisture and the Gulf Stream temperature contrasts. Then let's see, Friday. Friday we've got high pressure across the northeast U.S., and then we open the Gulf once again in Texas, and a warm day, fast warm up for Saturday. Snow showers in the mountains there. I think we've probably pulled the boundary northward. Something like that. Then for Saturday, just more of the same southerly flow across Texas. A new front coming south, but not much of a push behind that. And then for Sunday, very deep southerly flow. Strong pressure falls in Montana. So I think we've got a new weather system coming together. Temperatures in the 70s once again, 70s and 80s for Texas. Next Monday, about 8 or 9 days from now. And then we get a pretty good blast coming in for Tuesday the 14th. And that's a big one. The Gulf is wide open, so this could be a day where we might have some severe weather potential, probably from Oklahoma, possibly up to Missouri to Illinois. It's just something we'll have to watch. It's really, really too early to call that, but it does have the pattern that we would expect with some severe weather. Pretty good blast of cold air on Tuesday night. Yeah, this comes through Texas Tuesday, and then Wednesday everything moves eastward. And very rapid warm-up after that. And then for Friday the 17th, some more cold air coming in. And then high pressure across Texas like that. So, yeah, we're not quite up to Thanksgiving, so there's no way we really can tell at this point what the weather's going to do, but probably within a week that'll be in range. Okay, a quick look at the chat here. Sunday, it appears the next potential events for severe weather in the North Midwest states. Let me go back and look at that Sunday. Oh, yeah, there it is. In fact, yeah, I think I mentioned that earlier. I was talking about these showers. Yeah, we do have the Gulf open during the day Sunday, but it looks like it's open very briefly. If you go back to Saturday, yeah, here's the Saturday map. Yeah, a little bit of flow coming up from the south. Okay, yeah, we've probably got about 1 or 1.5 days of recovery, so that would probably be enough to support a little bit of severe weather there. So yeah, we'll have to keep an eye on that. So that appears to be Illinois, Indiana, Michigan, down to Missouri there. Further south, probably just not enough surface convergence, probably a cap. Conditions probably very warm in the mid-levels, and that's helping to suppress things. All right. Let's see. It's going to get hot for Ryan next weekend there in Florida. Low 90s and humid. Weak tropical storm coming from the eastern Bahamas, coming up the eastern seaboard. And Carl Burkhoff says Monday night has been a Packers game. Has a Packers game. Hope to still make it in for the webcast. So, yeah, we'll try to be back for that one. Well, that's probably all for tonight. I appreciate you all watching the webcast. And I'm going to leave you at the very end with some sounds of the woods here in Texas at night in November. It's deer hunting season for a lot of people, and we'll let you check that out. And otherwise, we'll see you tomorrow.